Class, this is the second of two videos for Tuesday, April the 21st, I think. So we have three classes left. Nearly all of you have submitted your work on test 2, but there might be one or two who haven't. Even if you're submitting late, you should go ahead and give me your work on test 2. You don't want to get a 0. Also, your quiz 5 has to be submitted by Thursday for full credit. And on Thursday, I'm figuring out what to do about the final exam. I'm in communication with my colleagues in the math department, and we are brainstorming about that, and I should have something worked out by Thursday, but I'm not quite ready to make an announcement. Okay, so we're moving beyond our Gauss-Jordan elimination, and we're entering new material in Chapter 4. So today's topic's actually quite elementary. I think this will be the easiest video to understand of any of them. Introduction to matrices, especially matrix multiplication. We'll get to this in about 5 minutes, but this is what we need to focus on primarily. And I'll show you a new way to think about it, possibly, even if you already know how to multiply matrices. Okay, a matrix is just a rectangular array of numbers. We have 5 examples of matrices down here. So for example, here are several examples of matrices. Let's take the first one. 3, -1, 2, 4, 5, 1. That's a matrix. I like to ask my students, have you used spreadsheets such as Excel? If you have, a spreadsheet that has numerical data in it is a matrix after all. It's a rectangular array of numbers. Now, how do we refer to particular entries? How do we refer to this entry or this one, for instance? Well, we use double subscripts. So remember this word, and we're going to keep coming back to this a lot. RICE, R-I-C-E. So RICE stands for row, R stands for row, C stands for column. Row comes first, then column. So we have row 1, row 2, column 1, column 2, column 3. So if we want to refer to the entry 2, it occupies row 1 and column 3. The way we express that is we say A1, 3 has the value 2. What about this one? This is in the second row in the first column, so A2, 1 equals 4 in this example. You don't even have to put the comma there. You can suppress the comma. You can just, this is a double subscript here, so you can say A13 is 2 and A21 is 4. No danger of thinking that this is a 13th entry because there are only 6 entries. Okay, so that's how we refer to particular entries. Now, adding and subtracting matrices is very easy. So what about A plus B, for instance? Well, you just add the corresponding entries. 3 plus 2 is 5. Negative 1 plus 3 is 2. 2 minus 1 is 1. 4 and 6 are 10. 5 minus 2 is 3. And 1 and 4 are 5. Nothing to it. A minus B, subtract the corresponding entries. 3 minus 2 is 1. Negative 1 minus 3 is negative 4. 2 minus 1 is 1. Whoops, made a mistake. 2 minus negative 1 is 3. 4 minus 6 is negative 2. 5 minus negative 2 is 7. Double negative there. 5 minus negative 2 equals 5 plus 2, which is 7. 1 minus 4 is negative 3. All right, that's easy. Now, another easy operation is multiplying by a scalar. Scalar is a synonym for number. So, let's have examples of that. So 3 times A, for example. Think of 3 times A as A plus A plus A, right? 3x is x plus x plus x, isn't it? So by analogy, 3A should be A plus A plus A, which means just triple each entry. In other words, if you have a scalar here, times a matrix, just multiply each entry by that number. 3 times 3 is 9, 3 times negative 1, 3 times 2, 4 times 3, 5 times 3, 1 times 3. And these operations can be combined, so what about 2b? 2b would be 2, 6, negative 2, 12, negative 4, 8. So if we wanted to find 3a plus 2b, this is 3a, this is 2b, so we would just add this matrix to this one. Okay, now those are the easy operations. What about matrix multiplication? It doesn't work the way you might think. So for instance, what about A times B? Oh, by the way, something I haven't mentioned. Let's see what the size of these matrices are. This has 2 rows and 3 columns, so it's 2 by 3. This one is 2 by 3 also. This one is 3 by 2. Now, is this 3 by 1 or 1 by 3? Remember the word rise. So it has 1 row and 3 columns, so this is 1 by 3. And this is, what about this one? This has 3 rows and 1 column, so this is 3 by 1. Now, we can't multiply A and B, it turns out. You might think all you would do is just multiply the corresponding entries, but that's not the way it works. Okay, so the easiest case, so now we're doing matrix multiplication. Matrix multiplication. So the easiest case is something like D times E, when you have a row vector by a column vector. row vector times column vector. So if a matrix only has one line, one row, one column, it's called a vector. This is a row vector, this is a column vector. So let's multiply D and E. We can do that, it turns out. Okay, now the first thing about matrix multiplication is the following. See what the sizes of the two matrices are, the dimensions. So this is 1 by 3, and this is 3 by 1. Remember the word rows. It says 1 row, 3 columns. It says 3 rows, 1 column. These numbers have to be equal or you can't multiply. In this case, they are equal. If they are equal, the answer is going to have this dimension. So it's going to be, in this case, 1 by 1. Only a single entry. So there's just one number that's going to go there. All right, how do we find that number? Here's how it works. You pair the numbers off. Here's a pair, here's a pair, here's a pair. You multiply each pair. So 2 times 1 is 2. 4 times 4 is 16. And negative 3 times 2 is negative 6. And you add these numbers. So in this case, that would be 12, wouldn't it? That's the number that goes here. Okay. Now let's look at A times C. This is the general case. I'll multiply this matrix and this one. Here's A. Here's C. Remember the word rise. So this is 2 rows, 3 columns. This is 3 rows, 2 columns. These numbers are equal. So we can multiply, and the answer is going to be, the dimensions of the answer are specified by the outer numbers. All right, let's do that calculation. So we have 4 numbers to find. Now let's pick one of them at random, and I'll show you how to find it. So let's calculate this number. Okay. Now we ask first, what is its position, keeping in mind the word rise? So what row is it in? Is it in the top row or the bottom row? It's in the bottom row. So we take the bottom row. What column is it in? Is it in the left or right column? It's in the left column. So we multiply the bottom row and the left column as I showed you previously. what would that be? 4 times 2, 5 times 3, and 1 times 0. And then you add these numbers up, so that would be 23. Now let's do this one. So this is in the bottom row in the right column. Right? Bottom row right column. Here's the bottom row right column. 4 times 1, 5 times negative 1, 1 times 5. So we add these numbers, and the 5's cancel. All right, that entry is in the top row in the right column. Three times 1, negative 1 times negative 1, and 2 times 5. 14. And this is in bottom row, top row rather, left column. Three times 2, negative 1 times 3, and 2 times 0. Add these numbers. So we put a 3 there. Okay, so if you did some matrix theory in high school, you work with this operation, and you, I hope, begin to see why we make this definition. If this is brand new to you, this must seem quite strange, but I hope the example was clear, and we will explore this further on Thursday. So don't forget, you need to submit your 5th quiz by Thursday to get full credit for it. All right, thank you, class.